All right, AP Physics, University of Texas Quest, Uniform Circular Motion, accelerometer in a car. A number of students asked about this one, and basically you have a plumb bob hanging from a car. So the plumb bob is going to be in uniform circular motion just with the car. And what it boils down to is a mass in a horizontal circle spinning around on a string. So I think once you see the free body diagram of this, it'll become a little bit clearer. Okay, here I've got the force of tension, and then I have the weight of the object. And here's our free body diagram. Remember now, we need this angle theta is given in the problem. Okay, the first thing that we need to notice is that this vertical component of the tension is going to be equal to the weight, and that's the key to solving the problem. Okay, so this force of tension has two components. One, a vertical one equal to the weight, and the second one is this x component. All right, now this x component, I've drawn it down at the mass here. That is going to be our centripetal force that is going to make the mass at the end of this string go into uniform circular motion. Okay, so from this free body diagram, the big deal that we have here is we need the x component of the force in the string. And how are we going to solve that? Well, we have the vertical component, Fty, is going to be equal to the weight, and we have this angle. So we can do a little bit of trigonometry. And we can set that trigonometry up and solve for Ft in the x. And Ft in the x, that is going to be our centrifugal force. And that we know is equal to mass times acceleration centripetal. All right, so let's just substitute in our term for Ftx. And there's our centripetal acceleration. Now, I think originally the problem asked us to solve for a velocity tangential. And we notice the masses cancel out. The theta is given. We know g. So we can calculate the centripetal acceleration, which is v sub t squared over r. Once I have the acceleration, I think the next part of the problem, we have to calculate r. That's easy enough because we're given the tangential speed, so on and so forth. Okay, I think this setup then will give you good to go on this problem.